All right, ready to dive in. Today, we're tackling neural networks, those digital brains you're hearing so much about.
They're really quite incredible when you think about it.
Absolutely. They power everything from, voice assistants to medical diagnoses, and we're cutting through the hype to really understand them.
And what truly sets them apart, what makes them so revolutionary, is their ability to learn from data, much like our own brains do.
So instead of being explicitly programmed for every scenario, they kind of learn on the job.
Precisely. They adapt and evolve based on the information they're fed, constantly refining their understanding.
So it's less like rigid programming and more like training, like teaching a neural network to recognize a cat by showing it, tons of cat pictures.
Exactly. And here's where it gets really fascinating. With enough data, they can pick out incredibly subtle nuances, those intricate patterns that even we humans might miss.
That's incredible. That's what gives them that almost human-like ability to perceive and interpret information, right?
Precisely. It's a game changer compared to traditional algorithms because it allows neural networks to handle ambiguity and complexity in ways we never thought possible.
That's amazing. So how does this whole learning process actually work? Do neural networks really learn like our brains do?
There are definitely parallels. Picture a neural network like a factory, but instead of assembling cars, it's processing information.
Okay, I can visualize that.
So raw data enters the input layer, which you can think of as the raw materials arriving at our factory.
The input layer. Got it. So what happens next?
That data then travels through these layers called hidden layers, and this is where the magic really happens.
Hidden layers. Sounds mysterious. What goes on in there?
It's like having specialized teams of workers, with each layer performing unique operations on the data, extracting features, identifying patterns. It's all about progressively understanding the information.
So sticking with our cat example, would one layer be analyzing edges, another one's looking for shapes, and so on, with each layer adding a new level of understanding?
Precisely. It's like a chef combining ingredients to create a complex flavor profile.
I like that analogy.
Each layer adds complexity until the data finally reaches the output layer. This is where the neural network spits out its prediction like, yep, that's definitely a cat.
It's mind-blowing how all of that happens in milliseconds every time we use something like, facial recognition, or ask our voice assistant a question. And speaking of real-world applications, where else are neural networks making waves?
Oh, they're everywhere. Every time you ask Siri or Alexa a question, there's a neural network working behind the scenes, deciphering your words, formulating a response.
It's easy to forget that even though I know voice assistants use this technology, it's still pretty amazing. I bet they're also the brains behind those eerily accurate recommendations we see online, right?
You hit the nail on the head. Neural networks analyze your online behavior, your likes, dislikes, purchases, you name it, to create a detailed profile of your preferences.
It's a little unnerving how accurate they can be, but it's clear this tech goes way beyond just entertainment and convenience. I've heard some incredible things about its use in medicine.
Absolutely. In healthcare, neural networks are proving invaluable. They're assisting doctors in analyzing medical scans, which could lead to earlier and more accurate diagnoses of diseases like cancer, for example.
It's really remarkable to see how neural networks are already impacting us in such profound ways. But I have to ask about the different types of neural networks, because you make it sound like there's this whole toolkit with different tools for different tasks.
You're exactly right. Think of it like you wouldn't use a hammer to tighten a screw.
Right.
So we have these specialized neural networks like convolutional neural networks or CNNs. They're the visual masters of the neural network world.
Oh, interesting.
They're incredible at analyzing images and videos. They break them down into these patterns and features that help them, for lack of a better term, see and interpret visual information.
So CNNs are what power things like facial recognition software, or even self-driving cars.
You got it. And their applications go even further. They're being used in things like art restoration and even to help identify diseases in plants.
Wow, that's remarkable. So we have the CNNs tackling the visual side of things, but what about tasks that happen in a sequence? Like how do neural networks understand language or analyze trends over time?
That's where recurrent neural networks, or RNNs for short, come into play.
RNNs, okay.
These are designed specifically to process data that comes in a sequence, which means they can remember previous inputs and use that information to understand context, to make predictions about what might come next.
So RNNs are the reason our phones can predict the next word we're going to type.
Exactly. They're like the grammar gurus, constantly analyzing patterns and probabilities in language.
That's fascinating. So RNNs are kind of like the storytellers of the neural network world, understanding how information flows over time.
You could say that. They're essential for anything involving sequence, like natural language processing, speech recognition, and even music composition.
This is all so incredibly fascinating. But I do wonder, as we delve deeper into this world, what are some of the challenges? I mean, no technology is perfect, right? There have to be some limitations.
Of course, you're absolutely right.
So what are we up against?
Well, one of the biggest hurdles right now is the sheer amount of data that neural networks need.
Oh, I can imagine.
Training them effectively requires massive, and I mean massive, data sets.
It's like trying to feed a hungry monster.
Yeah,
And I bet all that data processing requires some serious horsepower, too.
you're not wrong. Training a complex neural network demands an immense amount of computational power, which can be a significant barrier, especially for, let's say, smaller organizations or researchers working with limited resources.
So access to data and the power to process it, those are two major hurdles.
Exactly.
Are there any other challenges that we need to be mindful of as we sort of venture further down this road?
There is a rather crucial one we haven't really touched upon yet, and that's what's often called the black box problem.
The black box problem. Okay, what is that?
Well, while we can see the input and the output of a neural network, understanding its internal decision-making process, how it actually arrives at its conclusions, that can be incredibly complex.
It's like trusting a system to make important decisions without fully understanding the why behind those decisions.
Right, and that raises some pretty important questions, especially in fields like healthcare or finance, where stakes are incredibly high.
It does make you stop and think, especially as we're handing over, well, not control exactly, but as we're giving neural networks more and more responsibility.
Absolutely.
It's like we're trusting them with really important decisions, but we don't entirely get how they're making those decisions.
Exactly, and that's a valid concern, which is why a lot of research is now focused on making neural networks more transparent, more interpretable.
So it can kind of peek behind the curtain,
Yeah.
see the gears turning, so to speak.
Precisely. We need to understand the why behind their decisions, especially in areas like healthcare where the stakes are so high, right?
Absolutely. It's all about striking that balance, harnessing the immense power of neural networks, but also making sure they're developed and used responsibly, ethically.
100%.
So where do you see this technology heading? What does the future hold for neural networks?
Well, despite the challenges we discussed, the future is incredibly exciting. The research is exploding. We're seeing these constant
It
breakthroughs.
seems like every day there's a new headline.
Exactly. And scientists and engineers are constantly pushing the boundaries, making neural networks more efficient, more transparent, and ultimately more beneficial.
That's what I love about technology. There's always something new and amazing just around the corner. Imagine neural networks helping us solve some of humanity's biggest problems, like, I don't know, developing new medical treatments or even tackling climate change.
And we're already seeing those possibilities become reality.
Really?
Oh, yeah. Neural networks are being used to analyze climate patterns, to make energy consumption more efficient, even to accelerate the process of drug discovery.
Wow. It's incredible to think how much potential this technology has.
It's truly vast. We're just scratching the surface.
It feels like we're on the verge of this, I don't know, a technological revolution, and neural networks are leading the charge.
That's a great way to put it. And just like any revolution, there will be challenges to overcome, ethical considerations to address, but
It's not always a smooth ride.
exactly. But by understanding both the capabilities and the limitations of this technology,
We can steer it in the right direction.
precisely, we can help shape how it evolves and ensure that it benefits all of humanity.
It's a good reminder that we're not just passive bystanders in all of this.
Not at all.
We have a responsibility, I think, to engage with this technology, to question it, and to help guide its development, to make the world a better place.
I completely agree. We all have a role to play.
Well, that's about all the time we have for today's deep dive into the world of neural networks.
It's been a pleasure chatting with you.
As always, but before we go, I want to leave our listeners with a final thought. These digital brains are already reshaping our world, and their influence will only continue to grow. So, here's the question. What role will you play in shaping their future?